In this next section of our bonding and reactions unit, what we are going to look at is how we balance chemical equations. Now, we call them chemical equations, but we also can call them chemical reactions, and that's because they indicate that a chemical change is taking place. All of our chemical reactions have a basic setup, and they look kind of like this, where we have the reactants here on the left-hand side of the arrow. The arrow indicates that a chemical change is taking place, and then the products are on the right. So, in an example reaction we have here, we are taking carbon dioxide and water, and in this case they are combining to form carbonic acid, or H2CO3. So, in my reactant side, I have CO2 and H2O, and my product side is the H2CO3. Now, when we talk about balancing chemical reactions, what we are talking about and why we have to talk about this is because all chemical reactions have to obey something called the law of conservation of mass. The law of conservation of mass, in a sense, states that the number and the type of atoms on the reactant side have to be equal to the number or the amount and type of that same atom on the product side. In other words, the reactants have to equal the products. So if I flip back here and I look very quickly, I have one atom of carbon here on the reactant side, and I have one atom of carbon here on the product side. I have 2 plus 1 atoms of oxygen, which makes 3 on the reactant side, and I have 3 on the product side. Your textbook and other sources basically state this same thing, just in a slightly different way. The law of conservation of mass officially states that matter cannot be created nor destroyed. So basically that means I can't get rid of atoms, and I also can't make new ones where they don't exist. And chemical reactions have to obey this law. So what I'm going to do is I'm going to show you how we do this by following through some steps. And step 1, you really won't see, because we will actually be you will be provided with reactions that already have this step done, just to make your life a little bit more simple. And the first step is to write the formulas for the components of the reaction. So if you're given the words, you actually have to write the chemical formulas. So hydrogen would be listed as H2, oxygen would be listed as O2, and dihydrogen monoxide would be water. Let me erase that, sorry. Okay. Now, step 2 is where you will pick up this process, where you have to count the number of atoms of each element on both sides of the reaction. And we call this taking the atom inventory. And this is how it works. You find the arrow and you actually draw a vertical line. And that helps you to kind of visually separate your reactant side from your product side. Now, if we look at the reactant side, we need to list all of the elements that are present. I can tell an element is present because its chemical symbol is there. So if I look at the reactant side, I have 2 elements. I have hydrogen and I have oxygen. Remember that an element symbol, each of them always has a capital letter. So if you are confused, just count the number of capital letters. That tells you how many elements you should have. Now, if I look on the product side, I should have those exact same elements, and I do. I have a capital letter H and a capital letter O for hydrogen and oxygen. Now I actually need to count the atoms that are there. If I look to the right of the H, I see that little number 2, and that tells me I have 2 atoms of the hydrogen. And the little number 2 to the right of the oxygen tells me I have 2 atoms of the oxygen. Now, if I look at H2O on the product side, the 2 after the H indicates that I have 2 atoms of hydrogen in water, and there's no number after the O, and that is understood in chemistry terms to be a 1. Okay? All I am doing, I don't have to worry about how I got there, how I got from 2 hydrogens and 2 oxygens to make a water. That's not what we're concerned about. You will just be given these, and this is the step that you need to understand, the starting point for this. All you need to do is count them and list them. And we will be doing some more practice with this after we go through the initial process. Okay, so for some people who maybe learn a little bit different way, we can show it this way. 2 green dots represent each atom of hydrogen. Okay, and then I have 2 big white dots. Those are my 2 oxygen atoms. But if I look at what I get on the other side, the product side, I get 2 green dots, which match what I have, but I only get 1 white dot for oxygen. So as of right now, my sides are not equal to each other, and so I need to fix that. That leads us to step 3. Step 3 has us take and change the coefficients. Remember from math, coefficients are numbers that go out in front. And what this does is it makes the number of atoms equal on both sides to help them satisfy the law of conservation of mass. This is a multiplication process. So, if we take a look at our atom inventory that we have here, the hydrogens right now are the same. There are 2 and 2. But oxygen is not. I have 2 on one side and 1 on the other. So, I have to get that 2 and the 1 to be equal through multiplication. And I can do that by multiplying by 2 to get 2 over here. Now this number 2 comes up and becomes the coefficient there in front of the water. Now, I have to put it in front. I don't put it down here. We don't ever do that. That's not what we want to do. Okay, you have to put it in front of whatever is containing that oxygen. Now, if I have 2 molecules now of water, I not only now have 2 atoms of oxygen, but if I remember this is multiplication, 2 times 2 means I now have 4 atoms of hydrogen. So looking at my inventory, my oxygens are now balanced, but my hydrogens are not. So in order to get 2 and 4 to be the same, I have to multiply over here by 2 to get 4. So this becomes a 2 over here. And then I look and double check. I have 4 and 4, which is balanced, and 2 and 2, which are balanced. Again, looking at this in a picture representation, okay, if I put the 2, if I put the 2 there in front of my water, that means I add another entire water molecule. And so you can see I have now 4. That means I have 4 of my green dots and 2 of my white ones. So that means I need 2 more of my green. So when I double check it, I have 4 hydrogen and 4 hydrogen, and 2 oxygen and 2 oxygen. So now they are equal. Always make sure that you go back and double check that you have equal numbers on both sides, and then you would be done. Now, like I said before, one mistake that students tend to make is they change the subscripts. So to get the 2 atoms of oxygen, oftentimes what they will do is they will just put that 2 right after the oxygen instead of out front as a coefficient. Well, instead of then, if you look at the molecule it's created, it's not the same as what we had before. It's not water. Okay, so we don't change the subscripts because what we're not going to do is change our compound that we have. In this case, H2O2 is hydrogen peroxide, okay, versus H2O, which is water. Okay, this stuff is not good to drink. It's actually poisonous. This stuff is perfectly fine. And the only difference is that little atom of oxygen. Okay, so would you want to drink a nice cold glass of hydrogen peroxide? Probably not. So what you have to keep in mind is that molecule does not mean the same as that molecule. Now, some last minute tips here before we do some more examples. First of all, balance the types of atoms that appear in only one reactant and one product first. They're usually the easiest to start with. Save hydrogen and oxygen atoms until almost last. In fact, I do recommend that you keep them until last. In terms of the order, I would do everything else, and then I would do oxygen and then hydrogen. Now, we are going to be talking about, and I will show you in some of the examples, something called a polyatomic ion. There is actually a list printed in your blue reference folders that you will be using, and these polyatomic ions, as long as they stay together on both sides, if we see the same polyatomic ion on both the reactant side and the product side, they have many atoms in them. And we can actually treat them as a single element, and I will show you how to do that.